ALS, commonly known as Lou Gehrig's disease, is characterized by loss of nerve cells in the brain that specialize in communicating with muscle cells. Nerve cells in the brain coordinate movement, while those of the spinal cord communicate directly with muscle cells throughout the body. This loss occurs over time and at different rates in patients, but ultimately, all patients experience progressive muscle weakness in multiple body parts. Astrocytes, an important cell type within the brain, provide energy, nutrients, and survival factors to nerve cells. Microglia, other important brain cells, drive inflammatory responses against pathogens in the brain and spinal cord. In ALS, astrocytes lose their nerve support, and microglia promote chronic inflammation. Both of these contribute to loss of function and nerve cell death. Nerve cell death could also be caused by immune cell activation in the central nervous system, CNS. This includes resident microglia and invading immune cells acting together and releasing molecules that trigger a storm of inflammatory responses that worsen disease progression. NUROWN is an investigational therapy for ALS and other diseases caused by nerve cell death. NUROWN is believed to protect and support nerve cells and reduce nerve cell damage by increasing the availability of nerve survival factors and decreasing the release of inflammatory molecules by establishing a regenerative microenvironment. This investigational therapy involves taking the patient's own cells from their bone marrow and isolating and purifying specific cells, known as mesenchymal stem cells, MSCs. The MSCs are grown in an FDA-approved cleanroom manufacturing facility using Brainstorm Cell Therapeutics' proprietary NUROWN technology to make them into neuron cells that release high levels of neurotrophic factors, which help nerve cells repair, grow, and survive, and reduce the production of inflammatory factors. A lumbar puncture delivers NUROWN cells back into the patient via the cerebrospinal fluid, CSF. The cells travel within the CSF throughout the brain and spinal cord to support nerve cells and dampen inflammation. Patients in clinical trials receive treatment every 2 months, with the goal of delivering continuous benefit. Purified MSCs used to make NUROWN are frozen through cryopreservation technology, allowing a single bone marrow extraction to produce future treatments for several years. The symptoms of ALS and the start of nerve cell death can be seen long before the death of all nerve cells, creating a therapeutic window. This makes NUROWN highly suitable, as the time from thawing the purified MSCs to treatment is just a few days. NUROWN is also being investigated for treating acute respiratory distress syndrome. NUROWN is believed to help control immune responses and repair damaged organs in animal models by releasing exosomes, tiny packages that can carry powerful cargo of proteins and molecules between cells. Exosomes can control immune responses in a similar way to NUROWN, but with several advantages, including easier storage, formulation, and delivery to and within the brain. Exosomes may also be modified to carry unique cargo. Exosomes are stable and safe, making them a potentially attractive cell-free therapy for acute respiratory distress syndrome and other inflammatory conditions.